Hello, today I would like to present you my solution for predicting electrical energy output of a combined cycle power plant. So the objective of this project was to accurately predict the net hourly electrical energy output, PE, of a combined cycle power plant in megawatts. Since the target variable PE is a continuous numerical value, I classified this problem as a regression task. To measure my model's performance, I selected the mean absolute error, MIE, for average error, and the root mean squared error, RMSE, which penalizes large costly prediction errors. The R-squared score, coefficient of determination, was used to assess the overall goodness of fit. The entire process included data preparation, model training, and performance validation was done using Vertex AI AutoML, which is like I now have open on my screen in my computer. So I decided to create two models. Model 1, which is here in the training, this model, which has full feature model. It used all four given features: ambient temperature, exhaust vacuum, ambient pressure, and relative humidity. Model 2 had a reduced set of features, where I was dropping the ambient pressure feature. So I selected the linear regression algorithm. This is the simplest type of model, which makes it fast to train and, most importantly, very easy to explain how each input affects the final power output. So as you can see, here is a model type. I also performed in Vertex AI AutoML tabular regression, which is a linear regression algorithm. So moving further, Vertex AI automatically handled the data splitting into training, validation, and test sets. Vertex AI used a fixed validation set derived from the next sequence of readings after the training data. Afterwards, I use the performance metrics generated on this fixed validation set to manually compare and select my final model. So let's go to the models, to the final models, and compare them. So model 1 and model 2, compare. Yes. So based on the marginal improvement of the mean average error, model 2 was selected as the final best performing model for this project. The model achieved, both model actually achieved R-squared score of 0.963, meaning it successfully captured over 96% of the variance in the electrical energy output. The average mean average error, MIE, was only 2.462 megawatts. This small error shows that the predictions are very close to the reality. Also to be mentioned that the root mean squared error for both models were the same or are the same. So the model confirms actually that the ambient temperature and exhaust vacuum are the two most powerful factors controlling the power plant's output. Focusing on these two inputs is key to understanding and managing combined cycle power plant efficiency. Thank you very much for your attention.